Hello. So today we have a dictionaries. We'll be taking a look at dictionaries. Let's go. So again, let's take a look at the, you know, whatever it is, the reminder we have set for ourselves, right? So we have lists, which is mutable and order it, right? We can mute it however we want. We can remove a certain, let's say, values in a list, certain strings, certain numbers, anything, right? We can add in between, we can add in the beginning, in the end, and we can do all of these things. Now we have tuples. Tuples are unmutable. We cannot touch them as long as we know what's inside, so that like we can remove a certain value from there, or add some in a random order, right? But it is ordered though, like it's literally ordered, and but it's unmutable, right? Now we have sets, which is gonna be looking like that, and it's unmutable. It's unmutable and it's unordered. So again, the same. I think the logic goes for sets where, well, where like we can definitely use sets in a way like as long as we know a certain strings from there, and so we can remove them. However, again, it's unmutable and it's unordered, right? It will be generated in random order. Now, as we did some a little bit of reminder for ourselves, it's time to add a dictionaries because this is a part of it. Now we have dictionaries, right? Sorry, dictionaries. Okay, so how does the dictionaries gonna look like? Now, dictionaries, how they look just like that. However, there is this thing called key and a value. Um, we have a key and we have a value, right? We have a key and a value. Okay. Now let's read together. A dictionary is a collection of unordered, modifiable, which is mutable, paired key and value data type. Now, it turns out that the this is this is a mutable. This is mutable, right? Dictionaries are mutable, and I believe it's unordered, no? Or is it ordered? Let's see. Unordered. Okay. So it turns out that they are unordered and they are mutable. But they also have this key and value thing, paired data type. Okay, so we have we have it unordered as well. I'm just going to copy that. Right, we have unordered and we have key and a value as I have mentioned. And this is how does the brackets look like for dictionaries. The same for the sets, but except this is a dictionary now, right? Okay, so all right. Creating a dictionary. To create a dictionary, we use curly brackets, right? These are called curly brackets or the dict built-in function. So the same for set, the same the um, for the tuple, except there is no such thing I think as a tuple, but um, there's no such function as a tuple. But again, so we have sets, we have dictionaries function, we have lists function, except tuple, right? Okay, so all right, so we put comma after each key and a value. Remember this? So let's get this empty dictionary, and let's say uh, like we have this data point of a certain person. We have a data of a certain person here. We have his first name, last name, key and a value, key and a value, right? The dictionary above shows the value could be any data type, string, boolean, least tuple, right? So shows that the value could be any data type. So the value can be a boolean, list, tuple, set, dictionary, whatever it is. Even the list, you know. So as long as key is written in in a good format, just like a variable, I think it will make some good sense. Okay, it will correlate with each other. It checks the number of key and value pairs in dictionary. So we have a key. All right, so the length function, it checks the number of key and a value. So we have one. We take this as a one, right? It's not two. So 1, 2, 3, 4, right? Okay, example, the same thing. We have accessing dictionary items. We can access dictionary item by referring to its key name. So we have a key, 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 key. So we can access the item in the dictionary, the value, I think, by, yeah, we can access the, you know, value of a dictionary by its key, right? Without key, we won't have an access to its value. As easy as that, right? So, okay. And I would like to call these brackets a square like brackets, like a extractors, because they do look like a extractors. Let me actually, how to say, maybe show, demonstrate it or not, like excavators. You know, excavators, there are like um, excavators. Yeah, you see, it's like we got these two excavators, right? They also have like this circled, um, whatever it's called. So you see, like it extracts, and in between there is like a certain a key or a certain value or whatever it is. Yeah, so we have these extractors, excavators. I would like to refer that this way, which you see like extracts a key and it opens up the value, right? Okay, so if we want to print it, the first name, it will give us this, right? So we are accessing the values that we need by what? By the key, right? We need a key to access the value, right? So we need a key to open the door to see what's hidden inside it. So accessing an item by key name raises an error if key doesn't exist, right? Accessing an item by key name raises an error if the key doesn't exist, right? To avoid this error, first we have to check if key exists, or we can use the get method, right? The get method returns none, which is non-type of object data type if the key doesn't exist. So it turns out that we have a value. It turns out that we have a value, but we don't have a key. Is this how we refer to it? Yeah. So it turns out that like we get the access to the value by the key city, right? Since we don't have this key city in order to get into value, it gives us none. It gives us error, right? Okay, so we get it, right? If we need to get it, we just type get and the keys, and we need a key to open up the door, right? We can add new key value pairs to a dictionary. Okay, so we can add a new key and a value pairs to a dictionary. So, okay, let's say that we have key fifths and a value fifths, right? So we can, so in order to add, so since the dictionary is mutable, right? in order to add the key and a value, we gotta have this excavator pointed out to its key, right? We create the key and then we follow up with a value. So this key equals to this value. This key, right? So this key follows up with this value. So we are creating a new key and giving it a value, right? Another example. So we have person, job title, and instructor. So we don't have a key called job title, right? So we are creating a job title and we are making it equal to an instructor, right? So this key is being accessed by this instructor. And we have person skills dot append HTML. So we also can use append to give. Oh, it's for lists. Sorry. So we are using this key to access the case, right? And we are, since this is a list, we are appending an HTML, right? Okay. Interesting. We need more practice for that in order to really get what we're looking for. Okay, modifying items in dictionary. We can modify items in dictionary. So again, we have a key. So what we're doing is we are not creating an existing key, but we are referencing to an existing key and making it equal to value 1, right? So that's how you can make it happen, or otherwise you can create a new one, right? Okay, we'll practice along the way. We'll figure out some things. Okay. We can modify items in dictionary. Okay. Okay. First name. You see? Now the first name is Ayob. Ayob. Eob. Yeah, Eob. And the age is 252. So 2 years later, he turns to 252 years old, right? Okay. So yeah, that's how we adjust it. Now we have checking keys in dictionary. We use the in operator to check if key exists in a dictionary. We use the in operator to check if a key exists in a dictionary. Again, we use the in operator to check, okay, the same logic. Is key in a dictionary? Is key 2 in dictionary? True. Is key 5 in dictionary? False. Okay. Interesting. Removing key and value pairs from dictionary. Okay. So we have this pop again, the same logic goes. We have pop item removes the last item. We have del removes an item with specified key name. Okay, interesting, interesting. Removes all the last item. The last item. Okay. Okay. So we got this example. If you want to pop first name, it removes the first name item. Okay. If you want to remove the last one, if you don't know what's the last one, so we just remove by pop item. That's all. Now we have delete person is married, right? Let's say the person is. It turns out that the person is single, so it deletes is married key and a value altogether. Okay, changing dictionaries to a list of items. To a list of items. Okay. The items method changes dictionary to a list of tuples. Okay. Mm-hmm. Changing dictionary to a list of items. So the items method changes dictionary to a list of tuples. Okay, so we have this dictionary, and if we print this dictionary and do this item method, changes dictionary to a list of tuples. So it will change the dictionary to the list of tuples, like this. Now each pair, right, key and a value, becomes tuple, right? And as we know, the tuples are, you know, written with circled brackets, right? Here, tuples, unmutable, ordered. So since they are now turning into tuples, right? Since we are making them items, we cannot mute them. They are unmutable. Changing dictionary. So if we don't want the item in dictionary, we can clear them using clear method. Okay. So we can, if we don't want any item in a dictionary, we just can clear it out, right? Okay, we have deleting dictionary. If we don't use the dictionary, we can delete it completely, right? We can literally just delete, not just the proportion as before, as you can see, right? Not just the proportion, the certain part, the certain pair in the dictionary, but like all together, right? Without the excavations, right? Okay, copy a dictionary. We can copy a dictionary using copy method. So, like, let's say you have a fear that the original data might probably be deleted, right, by some of your evil colleagues. So, what you will do is you will, every time any updates happen, in the end, it will just copy, right? So, whoever decides to delete it, you got the copy of it now, right? So you just copy it. That's how you copy it. And so you give it a different variable, since this is now a different thing right here, right? Okay. So this is now a different variable, a different, how to say, a memory, um, separately but just copied. Getting a dictionary keys as a list. The keys method gives us all the keys of a dictionary as a list. Okay. Dictionary key 1, value 1, key 2, value 2, key 3, value 3. Getting dictionary key as a list. Keys method gives us all the keys as dictionary as a list. Interesting. All the keys. So only keys, right? So we're not counting values here, we're just counting keys. So it just, oh, okay. Okay, interesting. So we have these keys and the values. So values will be as a list, and also keys can also be as a list. Right. Okay, interesting. Interesting. So we completed it. Now I'm thinking about some ideas to implement, like to make use of dictionaries, you know. Hmm. Interesting. What can we do with dictionaries? Um, what can we do? You know what? Let's just try out the exercise for some time, then we'll see. Okay, create an empty dictionary called dog. Okay, let's create a dictionary called dog, right? Like this. So now it's a dictionary. Also, it can be a set unless there are pairs. Add name, color, breed, legs, age to the dog dictionary. And add first name, last name, length of dictionary. Okay. So um, we have a dog. Okay, name. We have a name for the dog. Okay. How can we call this dog? Let's call this dog Scooby-Doo. Scooby-Doo. I think that's how it's written. I don't know. Okay, we also have a breed. What kind of breed is it? Is it the Scooby-Doo? Okay. You know what? Let's just randomly say that it's... Oh, my bad. I forgot to write comma. Okay. Okay. We have a breed. Labrador or something. Labrador. Okay. Legs. Legs? What do you mean legs? What kind of legs are we talking about? Okay. Legs are long. Legs are long. Age. Okay. Age is 20. Age is 20. Okay. Let's just keep this dog's dictionary for now. And now it says to create a student dictionary and add first name, last name, gender, age, marital status, skills, country, city, and address as a key for the dictionary. Okay. Okay. Interesting. Let's do it. Student. We have student. We have first name. You know what? I'm not gonna waste my time writing first name. My bad. First name James. Last name is Franco. We have gender. Gender is male. We have age. The age is 30. We have, okay, marital status. Single, or maybe let's do it like married. Skills. What skills does our character have? Our character has skills like what? What skills? Okay. Python. Python. Can we have several values? Like, okay, like SQL. Can we have it? No, we can't. Okay. We have country. We have country. Forgot the comma, sorry. We have country Indonesia. Indonesia. We have city. City is what? What city do you live in? City, city, city. What's the capital of Indonesia? What's the capital of Indonesia? Okay. What is the capital of Indonesia today? Wow. Okay. Jakarta, okay. Can we see Jakarta? Wow, what a beautiful place. Okay, it's Jakarta. Jakarta, okay. What else? Address as a key for the dictionary. As a key for a dictionary, okay. We have address. Okay, you know what? Whatever address. Home 7. Get the length of a student dictionary. Okay, let's get the length of a student's dictionary. Okay. Alright, so we have print, we have length, we have student. 9. Okay. What else? Get the value of skills and check the data type. It should be a list. Get the value of skills. Okay. And check the data type. It should be a list. Okay. Let's get the values. How do you get, let's call it get value. And student dot value. No. Yeah, values. Okay. Print get value and print type get value. Sorry. Okay. We have James Franco male class dictionary values. No. It should be a list. It should be a list. Maybe we have to convert it to a list first. What do you think? Like, convert it to a list? Right? Let's convert it to a list. Like list get value. Like convert it. Now we can call it converted. And let's do it converted as well. Okay, now it's a list. Good. Modify modify the skills values by adding 1 or 2 skills. Okay, let's add 1 or 2 skills. Right? Do you know how to add? Of course I know how to add. It's a skill 1. Right? And we have skill 2, 3, 4. Modify the skill values by adding 1 or 2 skills. Okay. You know what? It's time to ask. It's time to ask. Okay. Can we add several? Can we add several? What? Can we add several values for one key in dictionaries in Python? Yes, absolutely. How do you do this? Adding values, append, using list, most common. Also, we are okay. Wait a second. Using a set if you want unique values. Mm-hmm. Okay, you know what? I think the whole point is understood. Like we have delete, we have another delete, we have clear, we have pop, we have pop item, we have a key, like checking it, right? We can check it. We can. What else can we do? Okay, that's all we can do. All right. So now let's move on to conditionals. It's time to move on to conditionals. We can do some chains. I think the easiest topic in Python is obviously strings, floats, and stuff like that, but the best one, the easiest one is probably a conditionals. Okay, let's start with conditionals. Alright, okay. So, okay. By default, statement in Python script are executed sequentially from top to bottom. Right. If processing, do you know what does that mean? So we have a logic in Python which goes like when you execute any code, right? Whenever you execute any code in Python, you got this codes lines of lines and lines and lines of code, and so the code will be executed this way, right? Line by line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and far more to come. So that's how it's going to be working. Python logic of Python works this way. And so if processing logic requires so, the sequential flow of execution can be altered in two ways. Conditional execution, a block of one or more statements will be executed if a certain expression is true. Okay. Conditional execution. Block of one or more statements will be executed if a certain condition is true. Okay. Repetitive execution. A block of one or two statements will repeatedly execute. For now, we're looking at not just the repetitive, but we'll be looking at only the conditional execution, not repetitive execution, right? We have if, elif statements, right? In this section, yeah, in this section we'll cover if, elif, else, elif statements. The comparison and logic operators we learned in previous sections will be useful here. Okay, if condition. In Python and other programming languages, the keyword if is used to check if condition is true and to execute the blocked code. Remember the indentation after a colon. Right, so we have if condition, this part of the code runs for truly conditions. Okay. A if this if so a equal to 3, we know that a equals to 3, and so if a is bigger than 0, print a is a positive number. Right, as you can see in this example above, 3 is greater than 0. That's why it's printing this string, right? However, if condition is false, we don't see the result. In order to see the result of falsy condition, we should have another block, which is going to be else. If else. If condition is true, the first block will be executed. If not, else condition will run. If condition, this part of a code runs for th truly conditions. Else, this part of a code runs for false conditions. Truthful, I think. That's what he meant to write, but okay. Truthfully conditions. Okay. Example. If, okay, we know that 3 is bigger than 0, but since our condition is asking if 3 is less than 0, right? Print is a negative number. Else, print positive number. So if there is no way that we can get any any number bigger than 0, because it's not even equal, so that's why we always get a negative number. So yeah, if it were to be like a positive number, right, it would have print like a positive number, but in our case it's printing a is a negative number. The condition above proves false. Therefore, the else block was executed. How about if our condition is more than 2? We could use elif. If, elif, else. Okay. If our daily life, we can make decisions on daily basis. We make decisions not by checking one or two conditions, but multiple conditions. As similar to life, programming is also full of conditions. We use elif when we have multiple conditions. So let's think about a scenario. Okay, this is a scenario. All right. So okay, it's a little bit of neural network, but it's not this much, right? Okay. Imagine that you are thinking of drinking coffee, right? And you either want to drink coffee, which is yes, or either you don't want to drink coffee. Are you sleepy? Now, that here's come the question: are you sleepy? Right? Are you sleepy? Right? Are you? This come as a question. So, are you sleepy? If your answer is no, right? If your answer, right? If your answer equals to no, right? Then print no. No. Like, would you like to? Okay, are you sleepy? Would you like to drink coffee? If you are sleepy, no, then you will not drink coffee, right? So this is a real life scenario. Like, do I like to drink coffee right now? No. Why? Because I'm not sleepy, right? So it's simple as that. But for programming, am I sleepy? Yes. So I think I'm going to drink a coffee, right? As simple as that. Okay. If elif, right? Okay. If a is bigger than 0, a positive number. If a is equal is less than a 0, then it's a negative number. Since this is either of it, because it's not saying like bigger than or equal to, nor does it saying less than or equal to, the else will give us a is a 0, right? Okay. If condition else code. Okay. A equals 3. Print a positive if, so we can also write it this way. A equals 0. Print a is positive if a is positive. Else print a is negative. In our case, a is positive, so it's going to print a is positive. We have nested conditions, which are like chains. We have example a equals 0, if a bigger than 0, right? And we also have another condition, which is nested condition. If a is equal 0, and if when divided, the modulo equals to 0 when divided by 2, modulo, which is remainder, equals to 0, then print a is a positive and even integer. Since we cannot divide 0 to 2, it's definitely not going to be this one. So else a is a positive number, right? If this condition is not being met, right? If a is equal to 0, a is 0. Else a is a negative number, right? So if we have, let's say, 4, right, which is divided by 2, and the remainder is 0, when we give it 2, 2 multiplied by 2 is going to be 4. So it will output a is a positive and even and also it's even an integer. Okay, we can avoid writing nested conditions by using logic operator AND. If condition and logic operators. If condition and conditions. If condition and condition code. Okay, let's see. A equals 0, a bigger than 0, and oh, here comes this Boolean logic, Boolean table. So we are playing a false, true-false game here. Boolean, true-false table. We are playing true-false here. Okay, so we know that again. Let's remind it once again for ourselves that false and false is a false. Okay, we know this. False and true is false because there is only one false. True false is false. True true is true. False false, false or false is false. False or true is true. True or false is true because we know that you, let's say someone is asking me a question. Would you like to drink coffee? Oh, wait a second. Okay, here comes the good example. Okay. Would you like coffee or tea? So I'm most probably a tea person, right? And someone is asking me a question. Would you like tea or a coffee, right? So it's like a 50-50 chance, and the person who's asking doesn't know that I am a, you know, a tea person. So when I tell him like, you know, you can pour whatever you like. So since there's a 50-50 chance, there is a possibility um, of catching true, right? And that's why when false and true comes together, false or true comes together, we always choose true, okay? But when it comes for false and true, since you like, would you like to drink coffee and tea? You know, that's a very stupid question, but the answer is gonna be like, I would like tea. So there's this like precise vision. So that's why when there is a precise like certainty, we are going to choose false for and. For or, there is a possibility of catching true. So yeah. Okay. I think I did not overcomplicate things. Okay, so if so this one is false. This one is also false. So we are not going to take a look at this now. So false and false, it gives us false, right? False and and false, because you cannot divide 0 by 2. So it's going to be false again. Now this is true. Else is negative. Now the OR logic. User James. Access level 3. if user equal admin, right? So if user equal admin or access level bigger than 4, then access granted, right? So in this case, it's not admin, which is false, and its access level is not is not bigger than 4 or even equal to 4. So false or false is going to give us false. It will not print access granted. Else, so it will print access denied. Okay, I hope that it kind of like clarified things. Now let's like maybe do 3 exercises and we'll wrap it up. Okay, so get user input using input, enter your age. If user is 18 or older, give feedback. You are old enough to drive. If below 18, give feedback to wait for the missing amount of years output. Enter your age, 30. You're old enough. Okay, let's do it. I know that this seems very easy for me, but it might not be the same for others. So, okay. It's something you have to be grateful for knowing something. And I would like to add this one point of view I have when you know thing in a perfection level, right? And you just skip over it because you assume that it's easy because you know that, and you assume that some other people will learn that easily while you don't explain it yourself, which is a total disaster, which is against against to any teaching style out there. All right. So as a teacher, as someone who knows something, not just a teacher, but as someone who knows something in a level of perfection, you should not neglect when someone asks you or someone careful listening to you, right? You should not neglect that, rather give the knowledge you already have, right? Otherwise that's not gonna work. Okay, let's just move on as quick as possible. All right, so we have this example. Enter your age. Okay, age equal input. Okay, enter your age. If user is older, give feedback. You're older enough to drive. Okay. All right. If age is less than 18, okay, print you are not old enough to drive. Now we have another condition, which is elif age equal. Okay, bigger than or equal to 18. Sorry, I think no, bigger than or equal to 18. Then print you can drive, right? You can drive. Now let's see. Okay, enter your age. Let's say I'm 17. Oh wait. Oh, my bad. It should be an integer. It's not a string. Okay, 17. You're not old enough to drive. Okay. 18. You can drive. How about like false? 100 years old, you can drive. I think 100 years old is too dangerous to drive, you know? It's just like a baby. Okay. It depends, man. It depends. Okay. Compare the values of my age and your age using. You are 5 years older than me. Okay. I think I'm not gonna, you know, read the rest. I think it's just understandable enough. Okay. Enter your age. So we can compare the gap. Okay. Let's see. Okay, so my age original, let's call it age original, right? Which is already an integer. Age original, my age is 20. Let's assume that my age is 20. And if age, no, wait. Yeah, okay. If age, okay, is older than age original, right? I mean less than age original. Um, okay. Okay, how do we do this? If age is less than age original, right? We're gonna do this print. Oops, what happened? We're gonna do this print. Come on. You know, my keyboard sometimes just glitches. Print. Oh, come on. You are younger than me. Two. Um, age original, right? Age original minus age. 2. Then we'll do this magic trick. 2 years. Okay. Now, if age is, let's say bigger than, you know what? Let's make it equal. Equal age original. Oh, so we are peers. Okay. And we have a leaf, another condition. We give it an age, like, right, an age bigger than age original. Print respect. You look way younger. It's a compliment, right? You look way younger than your age, brother. You are you are, right? So we got this age. This time the we got to subtract age from age original, right? Years older than me, right? Okay, let's start. All right, enter your age so we can compare the gap. Let's say my age is 32. Respect, you look way younger than your age, brother. You are 12 years older than me. Okay, interesting. Interesting. Okay, let's do 20. Oh, so we are peers. Okay. 13. Oh, come on. You are younger than me to 7 years. A little boy. Or a little girl. Okay. Alright, so we got it. We got it. Now we will be working out uh, another exercises, when we do this, uh, when we, as I have said previously, when we will be working on exercises, when we will be covering up you know, each of the topics, each of the topics exercise, right? In addition, we will be doing a lot more Python exercises. I think I will extend it for like 1 or 2 days in order to really like master the Python, and we will do a lot of interesting projects along the way. All right, thank you, and see you on loops and functions, I believe. Thank you.